Hello, good morning, everybody. Today we are going to solve paper winter 2018 1-2 paper of Physics 505 for O levels. So here on your screen, we have the first question. An apple falls from a tree. Which row describes the forces acting on the apple and the motion of the apple as it falls? When an apple falls, two forces are acting on it. Uh, One is the weight of the apple, which is acting downward, and the other is the air resistance, which is acting in the upward direction. The weight will be larger than the air resistance because the surface area of the apple is not that large, so the air resistance is not that large in during that fall. So the weight will be always larger than the air resistance, and there will be a resultant force in the downward direction, so the forces will are unbalanced, and due to the resultant force the apple will accelerate. So question number one, C is the option. And the apple will be subject to unbalanced forces and it will accelerate. On your screen, we have question number two. The table shows how the speed of four bodies A, B, C, and D change with time. Which body has an acceleration that is not constant? You can see on the first column, the time intervals are given. Each time interval is of the equal length. And in the second and the third and the fourth and the fifth column, you see we have A body, B body, C body, D body, and their respective velocities or the speeds are given. And the question is, which one is not moving with a constant acceleration? So acceleration is basically change divided by time. So a body which will have not equal changes in velocity in equal intervals of time will have not constant acceleration. So if you look at the change in velocity for the body A, in the first second its velocity change from 0 to 1, so the change of 1 meter per second. And the second second it changed its velocity change from 1 to 3, so there is a change of 3 meter per second. And in the third second the velocity change from 3 to 6, a change of 3 meter per second. So in equal intervals of time the change in velocity or the change in speed is not constant, so it is not moving with a constant acceleration. The choice is A. Question number two, the choice is A. On your screen we have question number three, and it says an engine pulls a truck at constant speed on a level track. The link between the engine and the truck breaks. The driving force on the engine remains constant. What effect does this have on the engine and the truck? Because engine is still producing the same amount of power, when the link breaks, the truck is separated from the engine. The load on the engine reduces, but its power is still the same. So what will happen? The engine will start accelerating, it will speed up, and the truck, because when the link will break the truck, the force provided by the engine on the truck to move forward has disappeared, and so the truck will slow down. So for question number three, B is the option. Now we have the next question. Question number four is on your screen. On which car is there a resultant force? When you will move in a circular path, although your speed might be constant, but because of the change in the direction, there will be, we will say, the velocity is changing, because when you move in a circle your direction on every instant has to be changed. So there is a change in the direction, so there is a change in the velocity, so there is acceleration. So when there is acceleration, there is there is there is a resultant force. And when a body moves in a circle, there is always a resultant force towards the center, and its direction is toward the center of the circle. We call it the centripetal force. So a car moving around a bend at constant speed, that will have a resultant force. B is the option for question number four. Question number five on your screen. A piece of apparatus may be used to compare the masses of two objects. We use balance to compare the masses. So for question number five, the option is A. Question number, let me reduce the size. Yeah, the next question number six is on your screen. The graph shows how the extension of a spring changes with the masses suspended from it when the spring is on planet X and when the spring is on planet Y. You know, the extension in a spring depends upon the weight of the load which is hanging with the spring, and the weight depends upon the gravitational field in that place or on that location, and that gravitational uh, you know if you are somewhere where the gravitational field is stronger, the body will have larger weight and it will produce larger extension in the spring. So let's say if you take for example, you take 2 kg mass, you see on planet Y the extension is 10 centimeter. For the same mass, the extension on the planet X is 30 centimeter. So on planet X, you can see the same mass produces 3 times larger extension. This shows that the planet X has 3 times larger or stronger gravitational field strength. For question number 6, the option is D. And let's move to the next question. Question number 7 is on your screen right now. And say two cylinders P and Q are made of the copper. The height of AP is twice the height of Q. The diameter of the P is half the diameter of the Q. Which statement is correct? Because they are both made of the same material, so they both will have the same density. No matter what is their dimensions, it does not matter. If they have larger dimension, they will have larger mass. If they have larger volume, they will have larger mass. The important thing is they are made of the same material, so that's why they both will have the same density. So for question number 7, the option is C. Now on your screen, we have question number 8. The tennis ball is compressed, work is done, and energy is transferred to the molecules of the air inside the ball and also to the rubber from which the ball is made. Which row is correct? Whenever you compress an object, its kinetic energy, you will observe when you compress something, its temperature will rise. Because the temperature rise, that is an indication that the kinetic energy of that thing has increased. Whenever you compress, normally the temperature rises. So the kinetic energy of the air molecules inside the ball should increase, and the temperature of the ball should also increase. Question number 8, D is the option. Increase. D is the option for question number 8. Question number 9 is on your screen. Paths are laid as shown between point X, Y, and Z. A person walks along the path from X to Y to Z and then back to X. What is the value of the total displacement and the total distance traveled? Displacement is the shortest distance between the starting point and the finish point. And the distance is the total length of the path which you followed when you moved from the starting point to the finish point. When your starting point and the finish point, they are the same point, then the displacement is 0. And the distance, we can find the length of the path, 5 meter and 12 meter and 13 meter. From X to Y, 5, from Y to Z, 12, and from Z to X, 13. 5 plus 12, 17, and 17 plus 13 gives you 30 meter. And so the displacement will be 0 and the distance traveled will be 30 meters. So B is the option. Question number 9, B is the option. On your screen, we have question number 10 is right now on your screen. Which diagram shows the addition of 4 Newton and 3 Newton forces? You know, these two forces are to be added, and he has used the triangular law, and this is head to tail rule. And when you use this triangular law, you place the first vector on the head of the first vector, you place the tail of the second vector, and then you join the tail of the first vector with the head of the last vector. That gives you the resultant force. A is the right diagram. The rest of the diagrams, their arrows are, their directions are not according to the head to tail rule. Okay, so the A is the option. Question number 10, A is the option. Next question on your screen is question number 11. The diagram represents a geothermal power station. Which useful energy transformation is taking place? In this, what we do, we take cold water, we pump the cold water into the earth, and it gets hot and it converts into the steam, and that steam comes out of this shaft, and that steam is used to rotate the turbines, and those turbines run the generators, and the generators produce electricity. So you see the final energy form is electric energy, and during that thermal energy was used. So D is the option that thermal energy is converted into electric energy. Question number 12 is on your screen. He says a motor used to lift a load of 0.50 meter vertically as shown. The load weighs 40 Newton. The power of the motor is 20 watt and the system is 25% efficient. How long does it take to raise the load? The input power is 20 watt and the efficiency of the system is 25 watt. The useful power which you will get, or which the power which will be used to do the work, that is only 25% of the input power. So 25% of 20, we can calculate it. 25 divided 100 multiply 20 and the answer will be 5 watt. So the useful power, the power which will be actually used to do the work, will be only 5 watt. So once you have the value of the useful power, we can calculate how much time it will take to do this work. The power formula is work divided by time. If you want to find out time, the formula will become work divided by power. In this case, the work is equals to weight multiply vertical height, and divided by time, you get divided by power, you get the time. So 40 Newton multiply 0.5 meter divided by 5 watt, and when you do the calculation, the answer will be 4 seconds. You can do this calculation on your register and you will get the answer 4 seconds. So C is the option for question number 12. On your screen right now you can see question number 13. Different liquids are poured into 4 different containers. In which container does the liquid produce the greater pressure? At the bottom of the container. The pressure of a liquid can be found by the formula. Pressure is equals to rho GH. Rho stands for the density, G is the gravitational field strength, and H is the depth of the vertical depth of the liquid above the point from where at which you are trying to find out the pressure. So the pressure of a liquid is rho GH. So for all these 4 liquids, calculate the pressure rho GH. For example, for the first body, the density is 1.3, the vertical depth is 50, and the G value is 10. Just put those values, although the units are not consistent of the G value, but it does not matter because they all will have that G value in them. So for A, B, and C, and D, calculate the pressure by the formula rho GH. For first body, A body, 1.3 into 10 into 50, the answer will be 650. For the second B body, 0.80 multiply 10 multiply 80, and the answer will be 640. For the C body, 1 multiply 10 multiply 60, and the answer will be 600. And for the D body, 0.92 multiply 10 multiply 75, and the answer will be 690. You can do this calculation on a register. And he said which liquid produces the greatest pressure? The D, because its answer is 690. So D will produce the greatest pressure. The pressure of a liquid is given by the formula rho GH. Okay, on your screen, question number 14. He says a rectangular block of metal has a weight 6 Newton and measures 3 by 4 by 5 centimeter. What is the smallest pressure that it can exert when resting on a horizontal? He's talking about a rectangular box, and it's a solid, and the pressure of a solid can be found by the weight divided by the contact area with the ground. We want to calculate its smallest or the least pressure it can produce. So the surface area, the contact area must be the largest. If you look at the dimension of the rectangular box given, if I will put that face on the ground whose dimension are 5 centimeter and 4 centimeter, its surface area will be the largest for the pressure. So if you put that face on the ground whose dimension is 4 and 5, its surface area will be 20 centimeters square, and then we can calculate the pressure. Pressure is equals to weight divided by contact area. and the weight is 6 Newton. 6 Newton divided by 20 centimeter square, and the answer will be 0.3 Newton per centimeter square. So the option is B. For question number 14, the option is B. Question number 15 is on your screen, a little bit tricky question. Air is trapped in a cylinder by a piston. The pressure of the air is P, and the length of the air column is 20 centimeter. The piston is moved through outwards until the length of the air column has increased by 40 centimeter. The temperature of the air remains constant. You can see here we have a piston here, and it's moving inside the cylinder, and the gas is inside the cylinder. And one thing you should understand is that when the piston will move, the length of the air column will change. For example, in the first situation, the length of the air column is 20. Then the piston moved further 40 centimeters towards the right. The new length of the air column will become 20 plus 40, 60 centimeter. Another fact you should remember is that when the piston is moving, although the length of the column of the air is increasing or decreasing, but the cross-sectional area of the air column do not change. The cross-sectional area in the first situation and the cross-sectional area in the second situation is same. The volume of the air is equals to cross-sectional area multiply length. For air trapped inside a cylinder, for air pressure or for gas pressure, we use that formula P1 V1 equals to P2 V2 when the temperature of the gas do not change. P1 V1 equals to P2 V2. And in the place of V1, volume 1, I can write area, cross-sectional area multiply length 1. And in the place of V2, the volume of the air in the second situation, and that can be written as cross-sectional area multiply length 2. So the formula becomes P1 V1 equals to P2 V2. P1 multiply A multiply L1 equals to P2 multiply A multiply L2. Because on the both side of the equation, area is same, so area and area will be cancelled with each other. So we will have P1 L1 equals to P2 L2. Put the values of L1 and L2. So we will have P multiply 20 equals to P2 multiply 60. So make the P2 alone, make it the subject of the formula. So you will have 20P divided by 60. So P2 will be equals to 1 by 3P or P by 3. So B is the option. You see, it involves calculation. Whatever I'm telling you, the calculation I'm telling you, please write it down on a register and do that calculation actually. And then you will understand how this calculation is done. For question number 15, B is the option, P by 3. B is the option. Now we are moving to the next question. Question number 16 is on your screen. It's a diagram of a simple barometer. The barometer is an instrument used to measure the atmospheric pressure. And in the barometer, the length QR from the level of the mercury in the tray to the top of the mercury level in the tube. That length represents the atmospheric pressure. If the atmospheric pressure will be larger, this length QR will be larger. And if the atmospheric pressure is less, the QR length will be less. A long tube full of mercury is inverted in a small dish of mercury. The mercury level in the tube falls, leaving a vacuum at the top. When the atmospheric pressure decreases, which length decreases? When the atmospheric pressure will decrease, the QR length will decrease. So C is the option for question number 16. When the atmospheric pressure drops, the length QR will become smaller. Question number 17 is on your screen. A cold bottle containing a drink is placed on a table on a warm day. Drops of water form on the outside of the bottle. Which process causes the drops to form? The air has water vapors in it. They are in their gaseous form. So when that air come in contact with the cold bottle, and those gaseous form, that water which is in a gaseous form, that converts into liquid, and the droplet of the water are formed outside the cold bottle. This process in which the gaseous water vapors are converted into liquid water droplets, this process is called condensation. His question was, which process causes the drops to form? So the question number 17, A is the option. Condensation. Question number 18 on your screen. Some gas is trapped in a closed container. The gas is cooled and the volume of the container is kept constant. What happens to the gas molecules? He says that the volume of the gas is kept constant and they have lowered the temperature of the gas. When you will lower the temperature of the gas and you will keep the volume of the gas constant, the molecules of the gas, they will start moving slowly and their kinetic energy will decrease. So D is the option, they move more slowly. Now on your screen we have question number on your screen we have question number 19. He says let me reduce its size because not all the options are not showing. Question number yeah, question number 19 is on your screen right now. You can see not the whole question is not showing, so let me reduce its size. Let me question number 19. Let me reduce its size. Question number 19 is on your screen. A 100-gram piece of solid lead at room temperature is heated after 20 seconds. It 22 seconds. It has all become liquid. The graph shows how its temperature varies with the time. The power of the heater is 320 watt. Which expression gives the specific latent heat in joules per kg of the lead? Okay, you see here, heating curve has shown, and he want us to find out the latent heat, specific latent heat. Specific latent heat is about when the state change is taking place, and on the heating curve, the state change is shown when the graph is becomes flat, and here from 15 second to 22 second, you can see the graph has become flat. So in these I mean 7 seconds, the state was changing. So in these 7 seconds, the I can calculate the how much heat is provided by the heater. So the power of the heater is given, that is 320 watt, and the time the heater was switched on is also given 7 seconds. So I can calculate how much heat was produced by that heater. So heat is equals to power multiplied time. 320 multiply 7, that will give you the amount of heat. And the latent heat is formula is amount of heat divided by the mass. The amount of heat is 7 into 320 and the mass is 100 grams. But if you look at in the question, when he asks you to find out the latent heat, specific latent heat, he used the unit kg for the mass. So that's why I need to convert that 100 gram into kg. So if you want to convert 100 gram into kg, you have to divide it with 1000. So 100 divided by 1000 will be 0.1 kg. So the latent heat is latent heat is equals to heat divided by mass. So heat is 7 into 320 divided by 0.1 kg. So it looks that C is the option. C is the right option. 7 into 320 divided by 0.1. So for question number 19, C is the option. So on your screen right now, we have question number 20. What increases when a liquid becomes a gas at its boiling point? At its boiling point, when something is converted when a liquid is converted into gas, the intermolecular spacings increases. Question number 20, C is the option. C, the molecular spacing. So on your screen, let me change this view. Question number 20 is done. Question number 21. Let me increase this. increases. Okay. Question number 21 is on your screen, and so it says two liquid in glass thermometers are almost identical. They contain the same quantity of the same liquid, and the diameter of their capillary tubes are the same. The only difference is that one thermometer is longer than the other. You see, when both the thermometers have the same amount of mercury in them and the diameter of their capillaries is same, so they will both have the same sensitivity. But one of them is longer, so if it's longer, it will have larger range. So the ranges are different and the sensitivity will be same. So question number 21b is the option that ranges are different, but the sensitivity is same. Which question number 22 on the screen, which statement about a water wave is correct? Water wave, he says the amplitude is vertical distance between a trough and a peak. That's wrong. The amplitude is half the distance between the trough and the peak, vertical distance between trough and peak. The B is the frequency is the number of troughs passing a point in 1 second added to the number of peaks passing a point in 1 second. That's wrong. The speed is the horizontal distance traveled per second by a peak. That is right. The wavelength is the horizontal distance between a trough and a peak. That's wrong. Because the wavelength is the horizontal distance between a trough and a trough and a peak and a peak. So C is the option. The speed is the horizontal distance traveled per second by a peak. Question number 23. You see, it's a question related to light, and we need a scale and we need a pencil to because we have to draw this. When you will be working, you will have a hard copy of the paper in front of you. So use a pencil and a ruler. And what you will do, we have to the diagram shows a thin converging lens of focal length f, where must an object be placed to produce a real image in the position shown. Here, the image is shown. He says this image is real. So I will trace it back to the object. So where the object should be placed. So for this purpose, we will use two rays starting from the arrowhead of the image. So I will place a ruler in such a way that I will join the head of this image and the optical center, and I will prolong this line behind or on the left side of the lens. What I'm saying is join the tip of the image with the optical center of the lens and prolong this line on the left side of the lens. Then join the tip of or the arrowhead of the image with the focal point on the right side and prolong this line until it touches the lens. Join the tip of the image with the focal point on the right side until it touches this lens. Then from that point on the left side of the lens, draw a line parallel to the principal axis, where this line and the first line you have drawn intersect with each other. That will be the head of the object, the arrowhead of the object. So most probably it will be intersecting right above the point A. So the object must be placed at point A. You see, to understand this question, you have to draw the lines, and then you will be clearly able to understand it. So please bring your scale and your pencil and draw them actually on the paper. Then you will be able to understand why I'm saying position A. Okay, on your screen, we have question number 24. White light is dispersed by a prism. Compared with the blue light, the red light is. Whenever the white light passes through the prism, the white light disperses it into its seven colors. And the we can remember the order of those colors by a word, Roy G. Biv. Roy G. Biv. Red, Roy B. Roy G. Biv. ROYGBIV. Roy G. Biv. Red, orange, yellow, blue, green, blue, and indigo and violet. So his question is, when white light is dispersed by a prism compared with the blue light, the red light is. The red light will be it will be refracted less, it will slow down less because it is above the blue color. So okay, so it will slow down less and is reflected less. Refracted less. Question number 24. A is the option. On your screen, you can see we have question number 25. A student reads the following in her physics book. The incident angle is greater than 42, which is the critical angle for glass in air. What is the student reading about? This line is clearly from the topic of total internal reflection. When you, if the angle of incidence in a denser medium is more than the critical angle, the process of total internal reflection will take place. So D for question number 25. D is the option, the total internal reflection. On your screen, we have question number 26. Which statement about radio waves is correct? You know, radio waves are sound waves. No, radio waves are used to kill cancerous cells. No, radio waves are used in TV and telecommunication. Bill, it's right. Radio waves have frequencies higher than those of visible light. That's wrong. So C is the option for question number 26. C is the option. Question number 27 is a numerical. Ultrasound used to map the ocean floor during one survey. The depth of the water is 1200 meter. An ultrasound pulse is sent from the surface, and when it returns to the ship, another pulse is sent immediately. In any period of 8 seconds, 5 pulses are sent down from the surface. What is the speed of the ultrasound? You know, in 8 seconds they have sent 5 pulses. So the time between one pulse and the next wave, or the one pulse and the second pulse, the time lapse between them is 8 seconds divided by 5, and you will get, uh, if you divide 8 by 5, you will get 1.6 seconds. So in 1.6 seconds, you sent a pulse from the bottom. Let's say you have this ship, and you sent a pulse, and it goes down. It's reflected from the seabed, and it is received back in the ship. This time in which the pulse goes and reflects and comes back, it takes 1.6 seconds. And because the bed of the sea is 1200 meter deep, so the pulse take or wave takes 1200, it covers 1200 meter, and then it comes back, it again covers 1200 meter. So 2400 meter distance is traveled in 1.6 seconds. If you want to find out the speed, so divide the distance traveled by the time taken. So 2400 meter divided by 1.6, and the answer will be 1500 meter per second. So the for question number 27, the answer will be 1500 meter per second. D is the option. Question number 28 is on your screen. The diagram shows the magnetic field pattern in the region between the north pole of the two bar magnets. North pole and the north pole are facing each other. You know, the magnetic lines, they come out of the north pole. And when you will face north pole and a north pole, from both the north poles, the magnetic lines will be coming out. The magnetic lines do not intersect. So B is the right option. For question number 28, B is the right option. Okay, we are moving to question number 29. Students are asked to describe an experiment to measure the resistance of a metallic conductor. Which description is correct? Whenever you want to find out the resistance of a metallic conductor, you will connect an ammeter to measure the amount of current in series with that resistor, and you will connect a voltmeter to measure the voltage drop across that resistor, and the voltmeter is always connected parallel to the resistor. So ammeter should be connected in series, and the ammeter should be connected parallel to the resistor, and then we can use to find out the amount of resistance. You can divide the value of the voltmeter with the value on the ammeter. R is equals to V divided by I. So D is the right option. Connect a voltmeter in parallel and an ammeter in series with the conductor, then use R is equals to V by I. Next, we have question number 30. The diagram shows three 6 ohm resistors connected to give various total resistances. What is the difference between the smallest total resistance and the largest total resistance? So smallest total resistance is possible when you have connected the three resistors in parallel to each other. And the total resistance of a parallel combination can be found by the formula of 1 by R equivalent is equals to 1 by R1 plus 1 by R2 plus 1 by R3. So 1 by R equivalent will be equals to 1 by 6 plus 1 by 6 plus 1 by 6. So value of the R equivalent will be 2 ohm. And when you want to find out the largest resistance, the three resistors must be connected in series. And when three resistors are connected in series, their equivalent resistance can be found by the formula that R equivalent is equals to R1 plus R2 plus R3. So 6 plus 6 plus 6, it will be 18 ohm. And the question is, what is the difference between the largest resistance and the smallest resistance? So it will be 18 minus 2, and it will be 16 ohm. So the option is D for question number 30. The option is D. Okay, next question on your screen. A wire of length 0.50 meter and a cross-sectional area 1 expo minus 6 meter square has a resistance of 0.75 ohm. Another wire of the same material has a length of 2 meter and a cross-sectional area of 5 expo minus 6 meter square. What is the resistance of the longer wire? Both the wires are made from the same material, so they both will have the same resistivity. And resistivity of the first wire and the resistivity of the second wire, the values will be same. And the formula for the resistivity is R multiply area divided by length. So resistivity 1 equals to resistivity 2. R1 multiply area 1 divided by length 1 equals to R2 multiply A2 divided by length 2. Just put the values. R1 is 0.75, multiply area 1 is 1 expo minus 6, divided by length 1 is 0.5, equals to R2 value we want to find out, into area 2 is 0.5 expo minus 6, divided by 2, length 2 is 2. So make the R2 alone, do the calculation, and the answer will be 6 ohm. Do it on a register and you will be able to understand. So the option is 6 ohm. So question number 31, the option is D. Okay, so we are moving to the next question. Next question is 32. He say defibrillator is a device. Defibrillator is a device that is used to give an electric shock to a patient's heart. You must have seen that when somebody has a heart attack, they give him electric shocks. They hold two plates like thing in their hand, the doctor, and they put it on the chest of the patient, and they give the electric shocks. Defibrillator is that device. So a defibrillator is a device that is used to give an electric shock to a patient's heart. It supplies an electric shock with energy 240 joules at an average voltage of 2000 volt for 10 millisecond. What is the average current it supplies? Okay, so voltage is equals to energy divided by charge. Remember that formula. Voltage is equals to energy divided by charge. And the voltage value is 2000 volt given to us, and the energy is 240 joules, that is also given. So I can calculate the amount of charge. So charge will be equals to energy divided by voltage, 240 divided by 2000, and the answer will be 0.12 coulomb. So I know the charge which flowed there. If I want to calculate the amount of current there, the formula for the amount of current is charge divided by time. The charge divided by time, I is equals to Q divided by T. The value of the charge is 0.12 coulomb, and the time is 10 milliseconds. But we have to take the time in seconds. To convert 10 milliseconds into seconds, you have to divide it with 1000. So 10 millisecond equals to 10 divided by 1000. So the answer will be 0.01 second. So I equals to Q divided by T, 0.12 coulomb divided by 0.01 second, and the answer will be 12 amperes. C is the option. For question number 32, C is the option. You can do this calculation on a register, and you will then clearly understand that how this calculation is done. Question number 33 on your screen. In a lighting circuit, the switch is placed in the live wire. We always put the switch in the live wire because when you open the switch, it will isolate, it will cut off the supply of the live current to your appliance, or it will isolate your appliance from the live current. A lamp in the circuit can be isolated from the supply. Yes, that is the right answer. Question number 33, A is the option. Question number 34 is on your screen. Which cable transmits electric energy at the highest voltage? The cables which are transmitting electricity from the power station to our homes, to our towns, those uh, cables have very high voltage. So a power cable between the towns, that could be the right option. Question number 34, C is the option. Those cables which are transmitting the electricity to our towns, they have very high voltage in them. Okay, question number 35 is on your screen. A thermistor and a light dependent resistor are connected in series. Which conditions give the least resistance? Because you know the thermistor and the LDR, they are connected in series to produce a combined least resistance. They both should have the least resistance. So we have to look for those conditions in which the thermistor will have the least resistance, and in which the LDR will have the least LDR, light dependent resistor, will have the least resistance. Thermistor gives least resistance when it is hot, and the LDR gives least resistance when it is in the light. So hot and light. So D is the option. Question number 35, D is the option. I hope you are understanding it. Question number 36 is on your screen. An oscilloscope is connected to a DC power supply. You know the DC power supply, its direction do not change, and the time base on the oscilloscope is switched off. What is seen on the screen of the oscilloscope? On the screen of the oscilloscope, you will see a dot because the time base is off. So you will see only a dot above the mean position or below the mean position. On the given diagrams, the option A is giving the right screen display when you will connect a DC power supply and you will switch off the power. You will see a dot above the mean position. A is the option for question number 36. So question number 37 is on your screen. He says, what does the alpha radiation given off by radioactive nuclei consist of? Alpha particles, they are like the nucleus of a helium. They have 2 protons and 2 neutrons. So alpha particles are positive. They are like nucleus of a helium. So in the option B is the right option. Question number 37, B is the right option. They are like the helium nuclei. Question number 38 is on your screen. Which statement about the reactor in a nuclear power station is correct? In the nuclear power station, you know, the process of fission take place. For example, we have uranium rods, we bombard it with neutrons, and the process of fission starts taking place, and lot of energy is given out, and that energy through the moderator is transferred to the boilers, and those boilers, they convert the water into steam, and that steam is used to turn the blades of turbines, and then those turbines, they run the generators and electricity is produced. So most probably question number 38, the right option is the C option. The reactor produces energy to boil water and to produce steam. That is the right option in question number 38. So on 39, question number 39 is on screen. The results of alpha particle scattering experiment gave evidence for which the following. In the Martian, this Martian experiment, alpha particle scattering experiment, they bombarded a gold foil with the alpha particles, and by that experiment they discovered that the atom has a nucleus. So D is the option, the nuclear atom. So for question number 39, D is the option. Question number 40 is on your screen. Which statement about 2 different isotopes of the same element is correct? You know, the isotopes of the same element, they will have the same proton number, but they will have different mass number. So isotopes have the same number of protons in them, but different number of neutrons in them. So he says both isotopes have the same number of electrons in the nucleus, maybe, maybe not. And so nucleus does not have electrons in it. Both isotopes have the same number of protons in a nucleus. That is true. And B is the option for question number 40. B is the option. I hope you have understood today's paper, and I'm so thank you very much, everybody, and have a good day. This was question paper winter 2018 1 2 physics 5054. Have a good day.